So this is a recap of what happened on the call because, again, I wasn't 100% happy with the recording that came out from it. And as before, that is to your advantage because it means that you've not got awkward silences while people are typing their answers. What I am going to do in this one is ask you to pause the video, give questions a go yourself before restarting the video, because it's really important you actually take the time to use this to its maximum effect. We started off the call with percentages, and just to remind you what a percentage is, 1% is 1 over 100, 4% is 4 over 100. Basically, percent means per 100. Now, how would you find 87% of 200? And a very carefully noted with calculator. I'm wondering, what would you type in? Pause the video, take 30 seconds, and figure that out. Okay, so on the call we had several people giving suggestions. We'll talk through them perhaps in a slightly different order, but it's equally important. Now, 87%, that is 87 over 100. Now remember, when you have fractions, you times by the top, divide by the bottom. So you would divide by 100, and because the 87's at the front is getting times. With BODMAS, it was probably highlighted to you a while ago that division and multiplication and addition and subtraction are actually on the same level. And some of your teachers might have written it like this, because it doesn't matter what the order of those is, they happen at the same time. So equally, you could have written here 200 divided by 100 times 87. You could have 200 times 87 divided by 100. The important thing is that that 100 is what you are dividing by. You're always dividing by that 100, and the other two are multiplying. Now, somebody raised the point that actually this is not the most efficient way of typing it into the calculator, because if you can swap between your percentages and your decimals, it's much faster typing in 0.87 times 200. And this would give you your answer of £174. This skill, although it's not a Nat 5 skill, it's really deeply embedded in one of our Nat 5 questions, and that is our appreciation and depreciation questions. I've written here because it's so important that you're able to recognise the difference between your percentages, that these questions will always mention per year, each hour, monthly, per annum, per week, weekly, minutes, per minute, per second. There is always something that implies this change happens more than once. So let's look at this first example. The interest earned on 3,800 at 4% per annum after 3 years. Now I'm just going to make it clear, the value I'm wanting to find in this question is total in bank. So I'm slightly changing it to find out what amount is in that bank account at the end of 3 years. There's two methods, the long method and the short method, but they both start the same way. You need to find your decimal. So in the long method, we have 100% and we add 4%. Why do we add 4%, you might ask? Well, interest always gets added on, okay? It never gets subtracted. So we've got 100 plus 4% is 104%. So the end of the first year, you have 104% of what you started with. But if we did 104%, we'd have to worry about our dividing. So we are just going to turn that into a decimal straight away by dividing by 100. The next step in the long method is as follows. You need to find out what the amount in the bank is at the end of year 1. You need to find what the amount in the bank is at the end of year 2. You need to find the amount in the bank at the end of year 3. And you need to do these calculations separately in the long method. So we start with 3,800 because that is your amount, and you times by 1.04 and you will get an answer for that. I would pause, take the time to put this into your calculator and make sure you get the same answer as me. So I've got 3,952. However, when we calculate the interest for the next year, it's really important that we recognise the amount in the bank has changed. It is now 3,952, but the interest is still the same. We're still timesing by 1.04. Again, take the time, type it into your calculator, make sure you are confident that you're getting the same answers as me. And for year 3, because remember we are doing this for 3 years, we take the amount, same as before, and we substitute that in. And we times it by 1.04. Again, take the time, make sure you are getting the same values as me without with the calculator. As we talked about in the call, we've got an issue here because that isn't the type of thing we started with. Our amount at the beginning was money. So we need to make sure our answer is also in money. So we need the pound sign. We need the whole numbers and we need 2 decimal places. So we're going to round to 48 because the bit after the 8 is to 3 and that means we round down. So there's your answer. Now, that is not the method your teachers will encourage you to use. And the reason is, as you can see, that is a lot of work. Your teachers will all have encouraged you to try the short method. So the short method starts the same. You're still finding that decimal and by turning the percentage into it. But if we look at what happened in the long method, we had 3,800 times 1.04. And that equals the answer of 3,952. But we then took that answer and we times it by 1.04. And then we took that answer and we times it by 1.04. And suddenly, even that's half their working. On the other hand, if you times by something 3 times, that is the same as timesing it by the cube of it. So our short calculation would be as follows. This is how I would write it out. After 3 years, just to be clear, you understand what you've calculated, 3,800 times 1.04 to the power of 3. Now you should get the exact same answer. Which means once you've rounded it, you will get the exact same answer. I want to make it really clear, all this information comes straight from the question when you do your small calculation. The amount, your multiplier gets added on, turned into a decimal, plugged into your calculation, and the time, or the number of years, the number of weeks, the number of months, is your power. In the tutorial, I asked everybody to give these a go themselves. They took 2 minutes. I would like you to pause, take 2 minutes, and try question 2 and 3 by yourself. So, for the next stage, I'm going to rub out everything that's here so we can still see the questions. And I am not going to do the long method for these questions. If you chose to do the long method, it does not really matter because you should be getting the same answers. So long as you didn't round early and you left the horrible decimals, your answers will be identical. So let's look at the information we've been given. We've been given the starting population. We've been given that we decrease by 6%, and we've been given the number of years. The buzzword was yearly at the end there, 6% yearly, implying that this percentage happens more than once. So, get your decimal, 100%. Now, what do you think happens when it decreases? Well, when it increased, we added. When it decreases, we subtract. So minus 6% to give us 94%, which you turn into the decimal. We're then going to our calculation. And to be really clear, we understand, we're going to say after after 4 years. The amount times the decimal to the power of 4. And I'll just color code that for you. So the amount times the decimal to the power, which is the number of years. You then type that into your calculator. Make sure you take the time to try this yourself so you are absolutely positive you are getting the same answers as me. And we look back at our question, we look at what we were measured in, what are we talking about? And you'll see that we're talking about population. Now, population, we're talking about whole numbers of people. So your answer has to be rounded to whole numbers. In the question, they might tell you to round down, they might tell you to round up. But in general, it must be a whole number. Now let's look at question 3. Again, we'll highlight the information that's important. So 3 hours, 30 are present. So that will be what we start with. And 42% per hour, we are increasing by 42%. Fantastic. So we get our percentage, 100% plus 42% is 142%, which we turn into our decimal by dividing by 100. So, set up the calculation. After 3 hours, we will have 30 times, and then we use our new decimal, and we use our power. So we're again looking at where that comes from, increasing by 42%. We've added the 42, that's given us our decimal, and that's gone straight into the calculation. 3 hours came straight from the question, and the amount also came straight from the question. These are your core skills when it comes to these calculations. I'm aware it could be a bit of a cacophony of colour, but blue is your population, your amount, purple is anything to do with your percentage, and yellow is your powers. Now let's look at the next type of question they could give you. These are something called reverse percentages. Now, the notion of a reverse percentage is quite simple, but it is, as it implies, the opposite of what you are comfortable with. Normally, you're given 100% and you're asked to find a smaller amount of it or a larger amount of it. In these questions, you are not given 100%. The value you have been given has already had something added onto it or something subtracted from it. And this means you might have 104% or 120 or 60% because something has already changed. And your job is to undo that change to find the original amount or the amount before the percentage was applied. Let's look at these questions here. So reverse percentages, find the original value. Well, remember the original value would have been 100%. It's increased by 6%. So instead of 100%, we have 106%. Your first mark comes from recognizing that 106% is £212. And like when you did percentages in the non-calculator questions, you had to build 10% building blocks and 1% building blocks. Here, we are going to build a 1% building block. So how do we get from 106% and split it up into 1%? Well, we're going to have to divide it by 106. But we can't just divide one side, this has to be equal. So you also divide the other side by 106 and you find that 1% is £2. How do you get 100%? Well, we've got 1%. You're going to multiply by 100. But again, you have to multiply both sides by 100, and that gives your answer of 200%. So in these questions, what do? You figure out what percentage you have, and it will not be 100%. You then take that amount and you make it equal to the value you've been given. So here, 106% equals £212. To find 100%, you break it up into little 1% and you times by 100. So it is the opposite of what you normally do. You normally divide by 100 times by the percentage. Here, you divide by the percentage and you times by 100. Now pause and give this next question a go. And what I'm going to highlight to you is that it decreases by 30%. How will that change your calculation? Hopefully you sat there and you realised, well, if it's decreasing by 30%, instead of adding on 30, you're going to subtract 30. And you know that you don't have 100% because you've lost 30%, you only have 70%. So 70% equals 105 grams. And your method is find 1% and then find the original 100%. How do you do that? Well, we're going to divide by 70 and that will give us 1.5. And then you are going to times by 100 and that will give you 150 grams. At this point, I would like you to clearly think through in your brain, what is the difference between these questions? If you are ever confused, I would always look for one of these phrases first, your per year, your each hour, your monthly. If there is not one of those phrases, then it's a decent guess that you're doing the second type of percentage question, which is your reverse percentages. Equally, if you're not confident recognizing the first type, the appreciation, depreciation questions, you have to recognize that you are given an amount after an increase has happened or after a decrease has happened. Or you're given an amount and it's really explicitly stated that it is not 100%. An example of that is the first exam question we have here. 480,000 tickets were sold for a tennis tournament last year. This represents 80% of all available tickets. If I had my highlighter in my exam, I would be highlighting that fact. Now, calculate the total number of tickets. So you've been told 480,000 tickets were sold and it's only 80% of them. What's the total number? So what is 100% of those tickets? 80% equals 480,000. We need to find 1% and we need to find 100%. So in your calculator, 480,000 divided by 80, you should get 6,000. How do we get 100%? You times it by 100, so you get 600,000. Make sure you put units on it. I know we normally think of units as pounds, meters, centimeters. It's important that you also recognise that it could just be something as simple as tickets. Looking at the next question, I'm going to give you a chance to pause, read it through, and give it a go yourself. There are 2.69 million vehicles in Scotland. It is estimated that this number will increase at a rate of 4% each year. If this estimate is correct, how many vehicles will there be in 3 years' time? Give your answer correct to 3 significant figures. So you're thinking, well, what sort of question is this? Your hint comes from the fact it says 4% each year. And it's going to be more than 3 years' time. So it's going to be in 3 years. It's not just 1 year's worth of percent change. And just to complete this, we start with 2.69 million and it is increasing at a rate of 4% each year. How many vehicles will there be in 3 years' time? Give your answer correct to 3 significant figures. We've taken out all the really important information there. The only thing you might also want to highlight is this bit here, because it would be quite easy to forget at the end that we have to round our answer. What type of question are we doing? We're doing appreciation, depreciation, but both questions do start the same way. You're taking your 100% and you're adding your 4% to get 104%. But with appreciation, depreciation, we have to turn that into a decimal. Set up your calculation. After 3 years, we take the decimal. Though, as I said in the call, if you did turn this into millions, so you had 2,690,000, that would be okay. You'll still get the same answer at the end. Times your decimal, which we found, and to the power of the number of years. And just to color code that for you, value, number of years, and your decimal, which came from the purple information. Following through, please take the time to put this into your calculator. Hopefully the answer you get out is 3.02588,416. And then we look back at that bit we highlighted, 3 significant figures. We have to round this to 1, 2, 3 significant figures. Now that 2, because it's a 5 that comes after, we are going to round up to a 3. And we are so close to being finished. But we need to make this millions, because that's what we started with. And we need to mention that it's vehicles. And there we are, we're done. Now, where do your marks come from? Because most of these questions are all 3 marks. Normally, you get your marks from the decimal, from setting up the calculation, and your answer. However, they've been very nice to you here, and they've given you an extra one for rounding to 3 significant figures. They won't always do that. And if this was a 3 marker, you would only get that 3rd mark after rounding. This is a very nice question. They're giving lots of marks in it. Okay, so let's look at the next question. Again, pause the video and think to yourself, what type of question is this? And if you're confident, give it a go. Hopefully you spotted that this percentage only happens once. Our value is only going to change once. And that's a good hint that you're using the reverse percentages. So we had 100%, 4% was added on, so we've got 104%. Now you're being asked the price of his holiday without the booking fee. Essentially, what was the original price of his holiday? And in comes that keyword original. And original means 100%. So we set it up as equal. And we find 1% and we find 100%. Pause the video if you haven't done this yet and give it a go yourself. Okay, hopefully what you found for 1% is you divided by 104 and you got an answer of £8.60. Now, you don't need it to be a pound sign at this point, but it does help you remember the sort of values you're dealing with. And then we times by 100 and we're getting our value of 806. Where do your marks come from in here? These ones are really nice to mark. 1, 2, 3. You get 1 mark for recognizing that the 2 things are equal. 104% equals 894.40. You get 1 mark for finding 1%. and you get another mark for finding 100%. The one thing you do have to be really careful of, and I'm going to write beware, is that you don't round too early, because in these questions you always multiply by 100 at the end. And if you round here, your answer might end up incorrect if you round too early. So what we did in the call was I gave hints for how to do the next 3 questions. So that's what I'm going to do just now as well. First step, can you recognize what type of question it is? Pause the video, read the question, and see if you're correct. Looking through, what's the key information? Well, the starting value we've got here, 250 milligrams, given to a patient at 12 noon. Now that sounds like it's something to do with our timings. The amount of the drug decreases by 20% per hour, every hour, and we're wondering what it is at 3 p.m. That is a lot of information in there, but the key one that tells you what type of question you're doing is the fact it decreases every hour. So together we will set up, and then I'll leave you to create the calculation and carry it out by yourself. First step, what is our decimal that we are going to be multiplying by? Well, 100% take away 20% equals 80%. That is a decimal, 0.8. We're then looking at our timings. So, how much time has passed? We're wondering about 12 p.m. to 3 p.m. So that's 3 hours. So with that information, we have our timings, we have our decimal. Now I'm going to leave you to create the calculation. A company buys machinery worth 750,000. The value of the machinery depreciates by 20% per annum. The machinery will be replaced at the end of the year in which its value falls below half of its original value. After how many years should this machinery be replaced? Now this is not your standard question. So I'm going to give you quite a few wee hints to give you the best chance at this you can have. First of all, let's think what the question means. What it means is you started with a value of 750,000, but once it's half its original value, the company is going to get rid of it. So you need to figure out how long that's going to be. Half of 750,000 divided by 2, you're going to get 375,000. Now, we also know it depreciates by 20% per annum. So yearly, it depreciates by 20%. Now let's look at the method for this. And unfortunately, there isn't an easy method. You're going to have to prove using the long method how this works. You're going to have to split it up and calculate year 1. You're then going to find out how much the machinery is worth in year 2. You're then going to find how much it's worth in year 3, year 4, year 5. Once you've done that, or as you do that, you will eventually get a value. Hypothetically, it might be year 2, that is less than $375,000. And when that happens, that year, is the year it will get replaced. So the year after it should get replaced. Okay, so to recap, machinery is worth 750,000. It will be replaced when it's less than half its original value. So you are going to calculate each year until the answer is less than 375,000, at which point year 2 or year 3 or year 4, the machinery will get replaced after that year. As before, if there's any questions about any of this, feel free to send me an email. You'll find it easily on Teams, and hopefully this takes you from the basics up to your hardest exam level questions.